So go ahead and pause the slide after we go over this problem and see how far you can get. We're given a balanced equation. 2 moles of ammonia react with 3 moles of copper 2 oxide to make 1 mole of nitrogen, 3 moles of elemental copper, and 3 moles of liquid water. We want to know how many grams of nitrogen can be made from 9.05 grams of ammonia reacting with 45.2 grams of copper 2 oxide. And if 4.61 grams of nitrogen are made, what is the percent yield? So let's write down what we're given. We have a balanced chemical equation. We're given 9.05 grams of ammonia, 45.2 grams of copper 2 oxide, and we're given that 4.61 grams of nitrogen are made. We want the theoretical yield of nitrogen, that's the maximum amount that can form, as well as the percent yield of nitrogen. So we know we're going to have to do a limiting reagent part of the problem, figure out what our theoretical yield is, which reagent will run out first. Once we figure out our theoretical yield, then we can calculate our percent yield. Now we're given masses, so we've got to get to moles, so that's why I have my molar masses here. And then once we get to moles, we can figure out how much nitrogen each reactant will form based on our stoichiometric ratios. According to our balanced equation, 2 moles of ammonia will make 1 mole of nitrogen, and 3 moles of copper 2 oxide will make 1 mole of nitrogen. So I'm going to start out with my ammonia. Get the right pen color here. Okay, I am given 9.05 grams of ammonia. So I've got to get from grams to moles. So I take my molar mass, and then once I'm at moles of ammonia, now I can get to moles of nitrogen. I can figure out how much nitrogen I'll make based on my stoichiometric coefficients from the balanced equation. So if I look at my math, my grams of ammonia cancel out, my moles of ammonia cancel out, my final units are moles of nitrogen, and when I have 9.05 grams of ammonia, I'll get 0.2657 moles of nitrogen. Now let's do the same thing for my copper oxide. I'm given 45.2 grams of copper 2 oxide. So the first thing I need to do is get that to moles, and I do that by dividing by the molar mass. And now that I'm at moles of copper 2 oxide, now I can figure out how much nitrogen I'm going to get based on my stoichiometric coefficients from the balanced equation. So 3 moles of copper oxide will make 1 mole of nitrogen. And my calculator tells me 0.1893 moles of nitrogen, and this is a smaller value than this. So the amount that I can make, my theoretical yield, is 0.1893 moles. Now what I need to do is get this to grams by multiplying it by its molar mass. And let me just point out that in my previous slide I wrote 0.1893. I actually corrected rounded. I should take it to 4. And my calculator gives me 5.307 grams of nitrogen. Now let's look at my sig figs. I should have 3 sig figs, so 5.31 grams of nitrogen. So this is now my theoretical yield in terms of mass, which is typically the way that they're going to want it expressed. And now we can calculate our percent yield. Remember, percent yield is actual over theoretical times 100. And our actual is given to us in the problem. 4.61 grams was actually made. In our theoretical, we just calculated 5.31 grams, and so our grams cancel out. And taking our answer to 3 sig figs, 86.8% yield. And this makes sense because it's less than 100%. If you got this right, give yourself a big pat on the back.